Okay, class. So we will going to have a record regarding this lecture for your chapter 2, lesson 1, and that is your statistics and probability for normal distribution and properties. So right now I'm using the explain part for you to be able to understand what do we mean on this part. Okay, so previously we have already discussed your discrete probability distribution, which is of course we are determining the probability distribution of your discrete random variables. This time we will going to know the probability distribution of your continuous random variable or your continuous random probability distribution. Okay, but your continuous probability distribution is given by or represented by your normal distribution. Okay, the term used for your continuous probability distribution is your normal distribution. So this is very important because your normal distribution is actually the one that is used in making inferences in statistics. That is why it is very important in your inferential statistics. Okay, so when we say normal distribution, it is actually another term used for that, or another term that it is known as your Gaussian distribution. That Gaussian distribution came from the name of a German mathematician named Johann Carl Friedrich Gauss. Okay, or Gauss. Okay, so your normal distribution provides a graphical representation of statistical values. Okay, so another take note for that, when we are defining an equation, we are using the symbol mu, mean. This is your symbol mu, that is your Greek letter mu, or known as your mean. Okay, so another term for that is your population mean. Okay, and your sigma, Greek letter sigma. This is your Greek letter sigma. Okay, this is your Greek letter sigma, and that represents your population standard deviation. Okay, so the graph that the graph that represent your normal distribution is called your normal distribution curve, or your normal curve. Okay, so before we will going to proceed and other discussion regarding your normal curve, first we need to deal with its property. So one of the properties of your normal curve is that it is symmetric. So when we say symmetric, that is there is an equal measurement in both sides. They have equal measurement and equal size. And of course, one properties that describes your normal curve is your bell-shaped curve. Okay, so bell-shaped with tails that are asymptotic to the x-axis. Okay, what do we mean by that? I hope you already have an idea with the word asymptotic. So when we say asymptotic, okay, here is an example of your normal curve. Okay, so when we say symmetric or symmetrical, okay, that only means that we have here the line in the middle. This line signifies that your mean is located at the middle. Okay, so when we say symmetric, your area to the right, or the measurement to the right from the mean, is also the same with the area or the measurement to the left from the mean. Okay, so as you can see, also it is bell shape. Okay, this is bell shape. Okay, so and tails, these are the tails. This is the what we call tails. Okay, that are asymptotic to the x-axis. So when we say asymptotic, it will going to approach, meaning it goes near to your x-axis. When we say x-axis, we are talking about the baseline, the line, the horizontal line below, or the x-axis. Okay, so it will going to approach your x-axis, but it will not going to touch your x-axis. Okay, we will going to discuss more about that on the properties. So now here are the properties that includes your normal probability distribution. Okay, of course, first it is bell shape. Okay, that another is the mean, median, mode are equal. Okay, take note of that. They are located at the center. So mean and mode is median and mode is represented by the mean. Okay, by the mean, because again it is located at the center here. Next, we have the curve is symmetrical. Okay, I have already explained that one. Okay, and next, the width of the curve is determined by the standard deviation of the distribution. Okay, so what do we mean by that? Later on, we will going to discuss about standard normal curve. Okay, so when we say normal curve, the width of the curve is determined by the standard deviation. So as you can see, we have datas. The datas or the x values. We call the datas as your x values. Okay, so we label your normal curve below. Okay, so whatever here, for example, the standard deviation is determined from one data going to the next data. Okay, so for example, mean to the first data going to the right, that is the distance between them or the width between them is determined by your standard deviation. Okay, so remember, if your standard deviation becomes smaller and smaller, your normal curve becomes thinner and thinner because the data will going to shrink or going near to each other. Okay, so next we have, and by the way, standard normal curve, that is why it determines the width, because it will going to know how far the data from each other. Okay, next we have the curve is asymptotic to the baseline. Okay, I already discussed about that. The tails of the curve flatten out indefinitely along the horizontal axis, always approaching but never touching it. Okay, so remember always that if you're going to draw your normal curve. Okay, so if you could hear people or experts say flatten out the curve. Okay, this is what they mean by that. Because as you can see on our current trend right now regarding COVID-19 or our data about COVID-19, from lower number, it going up, up here. So when we say flatten the curve, that only means we have already reached the highest possible peak, the highest possible number, and it will going down already. Okay, so that is what they mean by flattening the curve. I hope we already have I already explained what they mean by flatten out the curve. Okay, so but if the data is from going from lowest value going up, and that part, class, that is not flattening the curve. Okay, just like what is happening right now. Okay, so next, this one, take note of this. Symmetrical, and the area is 1, meaning the total area from the left going to the right is equal to 1. Okay. I'm going to explain about 0.5 or your 0.50, or another term is 50%. Okay. Where does it came from? Since the total area from left to right is equal to 1, that only means from the middle or from your mean going to the right, the total area is equal to 0.5 or 0.50 or 50%. And next, from the mean going to the left, that is also 0.5 or 0.50 or 50%. So as you can see, 0.50 plus 0.50, that is equal to 1. That is given by your symmetric property or symmetrical property, and your total area equal to 1. Okay? Okay, next we will going to have your does it represent probability, the proportion, or the percentage? Again, class, when we say area, that is also the same when we say probability. That also talks about probabilities, proportion, okay, and percentage. Okay, so again, your area determines the probability. It also determines the proportion, and it also determines the percentage. Okay, so probability, most likely we indicate area on decimal place or in decimal way. On the proportion, as you can see, area can also be expressed in fraction form, and for the percentage, of course, in percent. Okay, but all the same, we are all describing the same way, or they are all the same anyway. You can interchange the word based on how you describe them. Okay, so we will going to continue with our discussion, of course. Okay, so data can only cannot be only represented by bell shape or your normal distribution. So it could be, there is the what we call skewness, or it's skewed to the right. That only means there are more datas on the left, as you can see. And also it can be skewed to the left. Okay, and also there are also chances that your data can be jumbled up, meaning there is an irregular shape for that. Okay, but of course, when we say normalize or normal distribution, we are saying that the data actually is distributed equally, meaning the data to the right has the same numbers or measurement or equal to the data to the left. Okay, that is what we mean by normal curve. That is what we mean by normalizing. Okay, so let's continue. Okay, so last time I let you graph your data using your frequency only and your gather data. Okay, so I allow you to use either line graph, because of course this one is actually a line graph. This is a line graph. This is already a representation of line graph. But of course, I understand when we say line graph, we are connecting from one point going to, okay, this time, okay, here, line, that is your line actually. Okay, but this time we will going to represent that one using a curve. The yellow one determines your bar graph. Okay, so now, or your another term used for that graphical representation is your histogram for the bar graph or for your line graph. Okay, next. Okay, I have already discussed this one, the symmetry. And class, if you really want to have the detailed part of your normal curve, you can also measure the height of your curve. Okay, so for example, going to give you an example. This curve that we have here, this one. If you really want to know what is the height of your mean, this part, as long as you have your x data, your mean, and your standard deviation, you could actually solve for the height. But of course, I'm not going to discuss more about the height. I'm just going to make you represent it in a normal curve. Okay, so here is the formula for that. For your height, that is your f of x that determines the height of your curve, and you have this formula. Okay, so this is the height, otherwise it is 0, the height. If x is between negative infinity, yes, between negative infinity and positive infinity, and your, of course, we need to fulfill the condition, and your standard deviation is not equal to 0. This condition, this ordinated condition. Your mean should also between negative infinity and positive infinity, and your x value would also from negative infinity to positive infinity. Okay, so we will going to discuss more about that later on, of course, if you want. Okay, so for standard score, okay, remember always that you can transfer, or the proper term used for that is standardizing. Okay, from your normal curve, usually when we say normal curve or normal distribution, the values that is used for that is your x values to represent your normal curve. While when we say standardizing, we are using the c values for your standard normal curve. Okay? So how are we going to represent the standard normal curve here? Okay. So before anything else, how would we able to know using the graphical representation if there are some data? Okay, so we have here for your normal standard curve example, your mean is 1010, and then you have here the values to the left of the mean, that is your 990, 970, and 950. Okay, if we will going to convert that one into your standardized, or to standardize that one, or convert that one into standard normal distribution, guys, what we are going to do is simply we will going to use this formula. Okay, this formula. Okay, so here we have here for your standard normal curve, remember always that the mean is equal to 0 and the standard deviation, or represented by your sigma, that is always equal to 1. That is for your standard normal curve. No more other values for this 2. Okay. Next, for your normal distribution. For your normal distribution, here, your mean here would always change, depend on your data. While your standard deviation depends also on your data. But if you are given a graphical representation, so here, what is located at the middle would always be the mean. Next, the data to the left of the mean on your standard normal curve is represented by the negative values. Okay? But as you can see, standard deviation is given by 1. What do we mean by that? Okay, so there is, for example, from the mean to negative 1, there is 1 standard deviation. From 1 to negative 2, there is 1 standard deviation. And from negative 3 to negative 2, that is 1 standard deviation. Meaning, how far are the data from each other here? So, negative 1 to the normal distribution that is represented or given by 990. Your 970 is represented by negative 2. Your 950 is represented by negative 3. Okay. What we do here is we simply minus negative 1 minus negative 2, that is 1. Then 0 minus negative 1, that is 1. Here also what you're going to do is higher value, the next value minus to the previous value. That is, for example, 1010 minus 990, that is 20. So here we already know that the mean, the value in the middle is 1010. For the standard deviation, that is 990 minus 970, that is 220 also. And 970 minus 950, that is 20. Same goes with the right part, that is 20. And 130 is represented by your positive 1. Guys, that only means the positive value indicates that the values to the right of the mean, example here, are higher than the mean, while the values to the left of the mean represented by negative value, that means these are the value lower than the mean or below the mean. Okay, that's why they are represented by negative sign. Okay, so next is 1050 represented by your positive 2 and 1070 represented by 3. So as you can see, that is 1 minus 0, that is still 1. 2 minus 1, that is 1. And 3 minus 1, that is 1. So that only shows that your standard deviation is 1. Here, as you can see, 130 minus 110, that is 20. 1050 minus 1030, that is 20. And 1070 minus 150, that's still 20. So we can say now that the standard deviation for this one is 20. Okay. So again, your standard deviation, your positive value for your standard deviation, standard normal curve, for your standard normal curve represent the values to the right, meaning the values there are above the mean. And the values which is represented on your standard normal curve represented by negative symbols determines by the values that falls below or the values that are lower than the mean. Okay, so let's continue. Okay, so we will going to deal about this formula later. I hope you have already an idea about this, but if not, still I'm going to explain that one. Okay, so another thing to remember, the empirical rule. So when we say empirical rule, this determines the area to the left and area to the right. Example, on your standard normal curve that I've showed you, you have here 0, right? 0, -1, -2, -3. Okay, this is 1, 2, 3. Okay, how would you say that? Okay, for your standard normal curve, 0 plus 1. Okay, standard deviation here is 1, alright? Okay, 0 plus 1, your mean is 0. Your standard deviation is 1. So, 0 plus 1, that is 1. Next, 0 plus 2 times 1, that is 2. That means 0 plus, okay, this is 2, mean plus 2 times standard deviation. Mean is 0 plus 2 times standard deviation is 1. So that is equal to 0 plus 2, that is 2. Okay, and next, 3 for the 3. Okay, and also same goes with this one. 0 minus 1 for the standard deviation, that is mean minus standard deviation. So we have 0 minus 1. So that is -1. Same with 2. Same process. Okay, so let's go back. We're not going to do explore more on the minus. I know you already knew that. Okay, so now for this given, what do we mean by this explanation for empirical rule? That means if there is a 1 here, and there is a -1, and there is, -1, and there is 0. So that only means that the area from 0 to +1 is also the same to the area from -1 to 0. Okay? Another is the area from the mean going to 2, because this is 2, right? Okay, and the area from -2 going to the mean, okay, is still the same. Same goes with 3. So from the mean going to 3 has the same area from the mean going to -3. Okay, so next we have here, okay, so as you can see, the area from the mean going to mu, or mean plus standard deviation, which is your 1, is 34%, or 34%, convert that one, 34%, or 0.34. Okay, because maybe later on you're going to confuse why we are using decimal values. Okay, so as you can see, that is 34% also to the left, or going to the -1. Okay, how about 0 to -2? What is the area? Simple. That's going to be 34 plus 13.5 here. Okay, that is 47.5. Okay, also here, from 0 to -2, that is still 47.5. Okay, so that is what we mean here below. Okay, we will going to erase that one. Okay, there. So that means if this is 0, that means 0 to 1 is, or from -1 to 1, that is 68%, or 34% here, 34% here. Okay. Next. Okay, next we have 95%. That only means that from negative 2 to positive 2, that is 95%. But from mean going to negative 2, this is 47.5. This is also 47.5. From 0 to positive 2 and from 0 to negative 2. A total of 95%. Class, the empirical rule only talks about the equal measurement of, or the equal area of a certain value from the mean going to your C value or your X values to the left, and a certain value from mean going to the right. Okay, so it doesn't care if it's negative or positive as long as it has the same area. Okay, and also for the 3, that is you're going to add this is 99.7. That only means that it shows that from negative 3 to 3, that is 99.7%, or from your mean going to the left, that is you're going to divide at 1, we have 49.35%. And then from the mean going to the right or going to 3, that is also 49.35%. Okay. Okay, next. Okay, so here, so I've given you an example for z is equal to a, or for your x equals to a and x equals to b. If there are given values such as, or z values, which is given two values and determine the area between. For example, we have here this one. This means we're looking for the area that covers between A and B. Okay, or the value, the areas between x is equal to a given value A and B. So we have here, when we see a P of x between A and B, or a P using this one, that means probability of x between A and B, or probability of x such that x is less than B but greater than A. Okay, I hope you understand that one. So next, for the Z table. Okay, I know you're really this one is new to you. Okay, remember class, not to remember, but remember always, this is a reminder. Your Z values, the Z table is composed of two values. First is your Z values. Second is your areas under the normal curve. Okay, so when we say Z values, that is located on the leftmost of your table and the topmost of your table. Okay, and the rest of the table that is located inside, or less values that is located inside, are what we call the areas, the probabilities, the percentage, or the proportion. Okay, again, these four words are used interchangeably. Okay, so these are again your areas, these values inside, except the leftmost part and the topmost part. Okay? Okay, so let's go back. Of course, let's go back. So we have here example c is equal to 1. Okay. First, what you're going to do if it is a whole number, express that into 3 values. So that's going to be 1.00. Okay, so and then if you have already the 3 values, break this values into 2 parts. So the first one, that would be z is equal to 1.0 and z is equal to 0.00. Okay, why is it important that we break that one? This 1.00 in terms of tenths and hundredths. Okay, so because the hundredths part, this one, and your tenths, whole number with tenths part, we will going to use that to locate your area. So what is the area for this one? P, that is represented probability of z equal to 1, or simply P of 1. Okay? P of 1 or P of z equal to 1. That is given by, find this first on your vertical numbers. So that is 1.0. And then these 3 values here in your hundredths part, find it on the horizontal part. Okay, on this horizontal part, that is 0.00, that part. So find the intersection, that is the intersection or the values or the area for that one is this one or this one. Okay, this one. This is the area of z is equal to 1.0. Okay, let's have another example. Okay, the area is 0.34134. Okay, another example will be, how about, okay, we will going to erase that one first. Okay, how about if z is equal to negative 1.5? Again, class, we will going to use the same table here because the reference for these values is your mean, which is equal to 0. Okay, so again, express first into 3 digit. Okay, that is negative 1.50. Okay, so first that is negative 1.5, and next that is your 0.00. Okay, so where is your 1.5? Here, 1.5. Again, regardless if it is positive or negative. So that is 1.5 and then still 0, this one. Upper. Okay, so look, that is given by your P of z equals to negative 1.5 is equal to here 0.4331. Let's make it fit. Negative 1.5, that is 0.4319. Okay, how about next? We will going to have Another example. Another example for that. Okay, how about if it is, for example, we have wait for a while. Okay, another example is find the values or find the area. This is plus the reference for this one is your mean, okay? So find the area if, for example, z is equal to negative 2.55. Okay, 2.55. Okay, so first locate your negative 2.55. Wait for a while. Okay, so negative 2.55. Okay, z is equals to negative 2.55. Okay, first thing first. So that is composed of negative 2.5 and another is negative 0.05, right? Hundredths value, and then take this one and replace it to 0. So take this one out. Okay, this is the result. This is the result. And what remains is 5, right? So replace this part into this one to make it 0.05. Okay, so we have here 2.5 that is given by your this value. Okay, so 2.5. Okay, and then 0.05 this part. So we have here, okay, going down, of course. Okay, going down. Okay, oops, this is 2.5, this is 2.5, and then 2.5. So the value for, or the area of P of z equals negative 2.55. Intersection, find the intersection, that is 0.49461. That's the area. Okay, the next question would be, how would we able to graph that one? That's the question. Class, again, this one is based on your z table or based on your mean. So that means if we were going to graph this one, as you can see here, for example, okay, now we were going to have it using the values. Okay, so we will going to graph that one also. Okay, this one is clear already, how to get the area, or how to read it, or how to get the area using your z table. Okay, now that's for the mean, class, meaning if that is the case, this is your mean, this is your normal curve, this is, okay, 2 3, so 1 2 3, This is -1, -2, -3. This only means that the area for -2.55, which is here, that we are only locating the area on this part. Okay? Area from the mean, which is your 0, going to 2.55. So that area going to this part is, again, the area, let's see. What's the area? That is this is the area. The area for this one is 0.49461. Okay? Okay, that is from the mean going to -2.55 only. Okay. Okay, next we will going to use your formula now to solve for the mean. Okay, now to solve for the mean, for example, we have here example. Given a normal distribution mean of 10, okay, so since we're not given a certain sample size, so we will going to assume that your mean, that is a population mean, that is 10, and your standard deviation is 3. Okay, find the corresponding C value of A. X is equal to 8. Okay, so your X given value is equal to 8. Okay, now, we will going to use the formula. Okay, so the formula is given by Z is equal to X minus mu over standard deviation. Just simply substitute, that is 8 minus 10 over 3. Okay, so that will have 8 minus 10, that is -2, and of course over 3. And that is a continuous decimal, that is -0.6666 or 0.67. That is your C value is -0.67. Okay. So when we say -0.67, that is, again, we will going to have a new, okay, that is, for example, so we have your normal curve. Okay, we have here 0, -1, -2, -3. This is 1, 2, and 3. So that is -0.67 is somehow in the middle of near middle of 1 and 2. 7. Okay, let us check that one again. Okay, that is 0.67. So check this one, 0.67. Of course, 0.6 and 0.67. So intersection. Okay, this one and this one. That is 0.24857. Okay? Okay. So if you need extra examples, we will going to discuss that one also. Okay, so have a good day, everyone, and I hope you learned something regarding our topic. for today.